So Dr. Kim, who will be our next speaker, is head of the research center of the Korea Research Institute of Ships and Ocean Engineering, KRISO. And KRISO is one of the important research institutes in ships and ocean engineering, and ocean energy is an important research area of this institute. And I'd like to, Dr. Kim is heading this research center, and he will introduce to us the design of a 1 megawatt OTEC plant on the Octagonal Sevan type offshore platform. Please have the floor.
Thank you, Mr. Chairman. Good morning, ladies and gentlemen. Nice to meet you again here. OTEC experts from all over the world. I'm very happy to be here. The fourth International OTEC Symposium at home of Blue Rise. Today, I'm going to introduce about design of a 1 megawatt OTEC plant mounted on Octagonal Sevan type offshore platform. And I'd like to add on-land OTEC application from main topic and future plan to promote OTEC industry. As you know, this International OTEC Symposium was founded by Korea and United States from the joint project agreement in 2013. At the first symposium, I have introduced Korean OTEC roadmap. Korean OTEC team is going through this roadmap. Now in 2016, we are on second stage, demonstration of 1 megawatt OTEC during 2016 to 2020. At the second OTEC Symposium was held at Gosan, Korea. At there, I suggested OTEC grant for tropical island in tropical blue belt. The suggestion was accepted by Korean government. So we have launched the SSUA program as a small OTEC grant program. This will be introduced by my colleague named Hyeon-Ju Kim after a while. Third symposium was held at Kuala Lumpur in Malaysia, and I have talked about the technical readiness of OTEC to achieve sustainable development goals. At that time, I confessed that all we could design in detail for manufacturing might be 1 to 4 megawatt OTEC plant. Everything and all efforts are becoming history of OTEC. From the OTEC history from 1881, we could aware of that French scholar George Claude had generated 23 kilowatt in 1927, right? We are still around him. Tens of hundreds of kilowatt OTEC pilot plants. I am afraid that he was being very disappointed to us, current scholars and engineers, including myself. Fortunately, OTEC colleagues around the world are struggling to demonstrate pre-commercial OTEC plants and pilot plants. Completed OTEC pilot plants in the red symbol are marked in United States, Japan, and Korea, and the purple symbols in development are in Hawaii, Tarawa over Kiribati, and Martinique Islands. I am always praying that every OTEC plant could successfully demonstrate for OTEC realization. Let me talk about the 1 megawatt OTEC plant design. I am sure that all of you are very familiar to OTEC principle, as Blue Rise have played animation about OTEC principles. We have chosen simple Rankine cycle for OTEC pilot plant, but we have adopted R32 3-halomethane as working fluid for Korean OTEC cycle. We designed the 1 megawatt OTEC cycle based on 20 kilowatt pilot plant that was a downscaled model of a 1 megawatt OTEC plant. We applied surface seawater of 29 degrees Celsius as a heat source and deep seawater of 5 degrees Celsius as a heat sink from field survey of Tarawa waters in Kiribati. In 1 megawatt OTEC plant, more efficient turbine, pump, and generate could be adopted than small pilot plant. To operate 1 megawatt OTEC plant, we have to consume 35% of generating power from OTEC plant to operate seawater and refrigerant pump. So we can use a net power of 650 kilowatt from 1 megawatt OTEC plant. To verify performance of OTEC pilot plant and enhance the efficiency of the whole system of OTEC plant, we have manufactured the key parts such as turbine, generate, heat exchange such as evaporate and condenser. In 2013, and then we have fabricated 20 kilowatt OTEC pilot plant as a downscale model of a 1 megawatt plant in 2013. This shows the experiment and operation of 20 kilowatt OTEC pilot plant. Unfortunately, this video cannot work. So you can look at this video from my Facebook page named OTEC and SWET, OTEC and SWAC. Based on such a successful design, operation, and modification of 20 kilowatt OTEC pilot plant, we carried out detailed design of a 1 megawatt OTEC plant to install not only on offshore but also on land. As a next topic, let me explain you 1 megawatt OTEC platform design. There are some available candidates such as TLP, SPA, semi-sub, and FPSO, etc. Among them, we decided pontoon and Sevan structures for 1 megawatt plant in tropical waters of Kiribati. For detailed design of 1 megawatt OTEC plant, we surveyed and analyzed the design conditions with SPC and so on, such as design wave, design current speed, design wind speed, as well as bottom topography. Significant wave height was 3.9 meters, and period was 14 seconds, as 100 years over return period. Offshore platform was selected as a simple pontoon at first in 2013. And then we have upgraded it to octagonal pontoon in 2014. And then finally, we have devised the Octagonal Sevan structures in 2015. There are 4 decks for ballast tank, pump room, OTEC plant, and monitoring and residential room. And at the top deck, necessary sporting facilities will be equipped on. Basic shape and configuration were evaluated by numerical simulation and then proved by model test in ocean engineering tank in KRISO. Dynamic behavior of octagonal ponton and the Sevan structure with the damper were compared from model test in wave tank as well as numerical simulation. As you can see, heave and pitch motion of the basic type were reduced while we attached the damper to raw edge of hull as a Sevan type octagonal platform. Unfortunately, this animation also doesn't work. This just shows example of a model test without a damp and with a damp against a higher wave attack. From the model test, heave and pitch motions of the floater with the riser were fortunately found out less than case without damper. It means a riser. It means we can design and install a Sevan type octagonal platform with a riser can be positioned in tropical waters. We also carried out the fatigue analysis using multi-scale fatigue analysis model, which was developed by KRISO team. In the case of applying 1 megawatt OTEC platform to equatorial waters, fatigue life of riser was estimated to hundreds of years due to a lower wave attack in tropical waters. Structural analysis was done perfectly for Octagonal Sevan type OTEC platform using ANSYS. And based on numerical analysis, 4-point spread mooring system and subsea power cable were also designed as shown in this slide. This shows arrangement of required facilities on each deck. OTEC plant on second deck consists of 1 turbine generate plus 8 evaporates and 6 condensers. These design results were approved in principle by VV, French Restoration, in this year. I'd like to thank you again her expertise and best collaboration. If there is a someone from VV. However, we cannot avoid to postpone to install Octagonal Sevan type OTEC platform to meet demands on food, water, as well as electric power from Kiribatian people, who is threatened by climate change. We decided to conduct floating OTEC tests on rectangular ponton in coastal waters of Korea in 2018, and then we will transport it to South Tarawa to install that plant on land in the late 2018 or early 2019. So 1 megawatt OTEC demonstration plant will install on land at coastal area of South Tarawa. Same OTEC plant for Sevan platform will be manufactured and fabricated for on land. And cold water piper and warm piper will be deployed until 2018 by bottom pulling and lattice flotation methods. If we complete 1 megawatt OTEC plant on land and deploy pipelines, we will operate it to supply electric power of 5,000 megawatt hour per 1 year for Tarawa community. Furthermore, we can assist them to get water and food from cascade utilization plants using discharged seawater from OTEC plant. If they can be awarded ODA fund from Korean government or international organization, we will also try to get ODA fund for floating Sevan type octagonal OTEC plant in the future, maybe around 2020. If you can be awarded ODA fund, we hope to connect lots of octagonal modules surrounding the OTEC module to expand the space of living for island residents who is threatened by climate change. Then we can create self-sufficient artificial OTEC island onto these very large floating structures. This is another animation to explain how can we build up VLFS surrounding OTEC plant. It is also doesn't work, so you can see this animation from my Facebook page. If all of you, as well as potential donors with big money, can join into this project, we can build up this VLFS with OTEC in the future. Each module would be named the donor's name or that nominated by donors. Then OTEC can make one more bright history for human beings in the future. This postal stamp shows us our struggling to realize OTEC technology. I hope all OTEC plants can install and operate successfully in Kiribati and coastal waters and other areas to put concrete stepping stone for OTEC commercialization and to publish a new OTEC stamp again in the near future. Thank you. Thank you for your attention.
Thank you very much for presenting to us this fascinating scale-up ambition. Are there questions? Apart from where you can buy these stamps, but that's another one. Can you bring the mic?
Françoise Dubois from DCNS. Could you please tell us more about the intake pipe for the cold water? What type of material, of structure, and the length of the pipe?
Is your question, we are going to install cold water pipe as well as OTEC plant? Could you give me your question again?
Could you tell us more about the intake pipe?
Yes.
Yes, the material for the cold water.
Yes.
Yes, cold water pipe. Yes, the material, the structure, and the length of the pipe. How deep you are.
Yes, okay. We are going to use high-density polyethylene pipe for 1 megawatt OTEC plant.
Yes.
But we have to apply FRP for 10 megawatt or 100 megawatt OTEC plant in the future. And the length of cold water pipe is about 2.7 kilometers for land-based type. But 2.7 kilometers. But if we apply this system on offshore plant type, we can use only 1 kilometer long.
Okay.
What is the diameter?
Diameter is 1.2 meters in.
Thank you.
Yes.
Okay.
Thank you.
Yes, there is room for one more question, and there is someone at the back. Maybe it's a good, maybe you can mention your name and maybe all the others. If you have a question and you I have a question for the first time. Mention your name.
Martin Brown, Aqualis, Aberdeen. For the Sevan type hull form you selected, that structure doesn't roll and pitch very much, but it does heave quite a lot. How have you designed the cold water pipe attachment for heave?
That is a very difficult question to me, but we have analyzed and model test about that response of rise and floater against wave attack. So I can explain based on my materials after this presentation.
Thank you.
Okay, thank you once more. Dr. Kim, there will be probably a lot more questions, but we'll have the lunchtime to discuss it further. So thank you once more for your presentation. So